All right, before going on to the next problem, I wanted to take a break and show something that the book sort of skipped over. And that is where the spin operators came from for the Spin-1 system. It also skipped over where it got um, the states for the X and Y basis, but those come from experimental results. And I can go over how those were derived also if there's any interest there. But for right now, we'll just take the assumptions that the book gave us that these are the X states. I also have the Z states here. We're going to skip the Y. Doing the Y operator is basically the same exact thing as the X operator. It's a little bit time consuming. So just know that doing the SY operator is basically the same exact thing as the SX operator. But first we'll do SZ, that's easier. Just remember that if you apply the SZ operator to some state, let's just say the up state, let's do 1, 0, 0, then what we're going to get back is the eigenvalue, so h bar in this case, and then our state back, so 1, 0, 0. All right, so then we need to find out what SZ is. And remember when we did the spin-1 half system, we set SZ equal to A, B, C, and D, and then applied that to like our up state. And then we expected to get h bar over 2 with our up state back. Remember that. We're going to do the same thing here, except we're going to have a 3 by 3 matrix. So we're going to set SZ equal to, we'll give it some constant here, and then we'll say A, B, C, D, E, F, G, H, I. Okay? And then so we'll go ahead and do this. So again, we'll write K, A, B, C, D, E, F, G, H, I. Okay? And then multiply it by our upstate. Okay, that's going to give us, looks like it's going to give us our K still. And then it'll be A, D, and G. And that's going to be equal to this here, H bar 1, 0, 0. So we can see that A is equal to, well, our K is equal to H bar. A is equal to 1. D is equal to 0, and G is equal to 0. We can go through each of these. So we'll do 0, 1, 0. And what we expect that to give us is 0 h bar, is what 0 gives us, is 0 h bar, 0, 1, 0. But because we already defined K as h bar, let's leave that as 1 h bar, but then this would be 0. It would end up being the same thing. So 1 h bar times 0 is 0, or 0 h bar times 1 is 0. Either way, it's going to be the same thing. So we'll leave it as that. And then so we'll see that this is going to become B, E, H. H, there we go, the center column there. So now we know that B is equal to 0, E is equal to 0, and H is equal to 0. And then finally we'll do 0, 0, 1. And that's going to be negative h bar is going to be the eigenvalue there, 0, 0, 1. Or again, because we want to keep that as positive 1 h bar, we'll move that negative sign in there. So this is going to be our third column vector, C, F, I. And now we know that C is equal to 0, F is equal to 0, and I is equal to negative 1. That gives us the matrix. So SZ can be represented, SZ can be represented by the matrix 1, 0, 0, 0, 0, 0, 0, 0, negative 1. Okay, that was the easy one. All right, so now we'll go ahead and let me erase this so it doesn't get confusing, leaving it up there. And we'll call this SX now. All right, so we're going to apply our SX operator to our SX states. So we'll start here. That's going to be 1 over 2, 1 over root 2, and 1 over 2. Fill that in here in a minute. And then we expect to get back positive h bar, and then our state back. So 1 over 2, make that a little bigger. 1 over 2, 1 over root 2, and 1 over 2. Okay. So if we multiply this across, we're going to get 1 half a plus 1 over root 2b plus 1 half c going to be equal to the corresponding value here, which is going to be 1 half. And then it's all, these are each going to be the same. So 1 half d plus 1 over root 2 e plus 1 half f equals that value, so 1 over root 2. And 1 half g plus 1 over root 2 h plus 1 half I is equal to 1 half. Okay, so not enough information to solve this system of equations yet, but we'll move on to this zero state. So that's going to be 1 over root 2, that on the outside, and then 1, 0, negative 1. Or we can just put that on the inside, keep things consistent. So let's do 1 over root 2, and then this is going to be negative 1 over root 2. And over here, we got 1 over root 2. So actually, again, this is going to give us 0 h bar. So we'll just make these zeros, 0, 0, and 0, which will end up being the same. 0 times anything is going to give us 0. All right, so then we're going to multiply these across, and it looks like we're going to have 1 over root 2a, 0b, and then minus 1 over root 2c. That's going to be equal to 0. Well, for this, we only have 2 terms here, so then we can say that 1 over root 2a equals 1 over root 2c. We can also see here that these cancel out, and we have a equals c. So that's good to know. So let's write that here. So a equals c. Because we did that for this, we can see that the other ones, that's going to happen also. Because 1 over root 2d minus 1 over root 2f. So we also can see that d equals f and g equals I. So that's going to help us. Not quite enough information, so we see that a and c are equal, but we're still left with 2 variables. So let's go ahead and do the minus 1 state. So that's going to give us, up here, 1 half, negative 1 over root 2, and 1 half, positive 1 half. All right, and then so that's going to be the negative h bar eigenvalue. So we'll just flip the signs of these to keep this positive. We'll flip these signs, say negative 1 half, positive 1 over root 2, and negative 1 half. All right, so that's going to give us, so we'll get rid of this. We already wrote these here. All right, so that's going to give us 1 half a minus 1 over root 2b plus 1 half c is equal to negative 1 half. 1 half, there we go. And these are all going to be the same coefficients. So 1 half d minus 1 over root 2e plus 1 half f equals positive 1 over root 2. And we have 1 half g minus 1 over root 2 h plus 1 half I equals negative 1 half. And that comes from there. Okay, so now we can start to combine things. So because we know that these, let me move this somewhere else. Let's do a equals c, d equals f, and g equals I. We also don't need this stuff anymore. That was from our SZ. All right, so I can erase this now. Okay, so because we know a and c, are equal, we can just make one of them the other. So this is A, and that's also A. So we have a half an A and a half an A. That makes a whole A. So we have A plus 1 over root 2B equals 1/2. And also we have another A, B, and C. So again, we can combine, we can make C into A. So we have half an A and a half an A, which makes an A. And we have minus 1 over root 2B equals negative 1/2. Well, if we just add these two together, that cancels out our B's. Also cancels out our 1/2. So we have 2A equals 0 or A equals 0. We also know that A equals C. So we know that A and C are both equal to 0. Okay. For this next one here, we can do the same trick. So we have D and F, which are the same. So we have a half a D and another half a D. So let's make that D equals, not equals, D plus 1 over root 2E equals 1 over root 2. And then our other DEF term here, we have D minus 1 over root 2E equals 1 over root 2. Okay, so we're going to add these two together. So we'll have 2D. These cancel out, and we'll have 2 over root 2. And then, so D is going to be equal to 1 over root 2. And D and F are the same. So D and F are both equal to 1 over root 2. Okay. And then we'll do G and I, and then we'll come back to do the ones in the middle. So we have G, same thing. So half a G and a half a G. Plus 1 over root 2H equals 1/2. And G minus 1 over root 2H equals minus 1/2. We can see that these are going to cancel out. These are going to cancel out, and we'll have G and I are both equal to 0. All right, so because we have that, so we know that A and C are 0. So then that means that 1 over root 2B equals 1/2. If we multiply across our square root of 2, then we have B is equal to root 2 over 2. This is the same, by the way. So 1 over root 2. If we were to rationalize the denominator by multiplying both the numerator and denominator by root 2 over 2, then this becomes root 2 over 2. So root 2 over 2 and 1 over root 2 are the same thing. So I'll say that B is equal to 1 over root 2. All right, and then our E is going to be, so D and F are 1 over root 2. So we have a half of 1 over root 2, another half of 1 over root 2. That's going to give us 1 over root 2. 1 over root 2 plus 1 over root 2E equals 1 over root 2. If we just multiply across our root 2, then we have 1 plus E equals 1, right? And then E is going to be equal to 0. So E is equal to 0. All right, and then H, I think is the only one we have left now. All right, so G and I are both 0. So we're left with negative 1 over root 2H equals negative 1/2. Negatives will cancel out. And then so multiply across root 2. So H is equal to root 2 over 2, which we already said is the same thing as 1 over root 2. So H is equal to 1 over root 2. So that's going to leave us the matrix, if we can find all of our letters here. So Sx is equal to A is 0. B is 1 over root 2. Also, remember, we did have an H bar over here somewhere. So we have an H bar on the outside. C is 0. D is 1 over root 2. E is 0. F is 1 over root 2. G is 0. H is 1 over root 2. and I is 0. And we can pull out the 1 over root 2. So then that would be, simplified version would be h bar over root 2 equal to 0, 1, 0, 1, 0, 1, 0, 1, 0. So that's how that came about. And again, sy is almost the same thing, except there's i's in there instead of ones. But the math is pretty much the same, so I won't go through that. So anyways, I'll move on to the next problem now, which is going to be to find the eigenvalues and eigenvectors for these operators. But I kind of wanted to show where those came from first.